The third circuit gets a little bit more complicated. Here we have an automatic cylinder control with speed and force adjustment. Aluminium plates are pressed in a pneumatically driven press in the following sequence. Blade plates are placed in position by hand. The start signal is initiated by means of a push button, whereupon the cylinder moves forward slowly to prevent damage to the workpiece. The return movement is automatic and must be executed faster than normal to cut down production time. The cylinder must return to the rear end position before the start of another working cycle. So you can see the difference with this one is that we have some automation in the circuit. So it moves out and moves back automatically. So let's have a look at our circuit design. Once again, we will start with our air supply, and I've added a double acting cylinder that's going to do the extending and retracting of the machine. In order to have automation in our circuit, we have to sense where the cylinder position is. So that means we need limit switches on the retracted and extended position of the cylinder, and we've labeled them A0, cylinder A. The 0 position is retracted, A1 is the extended position. So if you can just imagine a valve in each of those positions, or a limit switch with a built-in valve in each of those positions. The valve will be indicated on our diagram. So there is our air service unit as normal. We have our start button, which is the same as our previous diagrams, which is a 3 two-way valve. It is manually activated and spring return. Now we're including 2 limit switches. These are roller follower switches, and you can see that they've been labeled A0 and A1. So they are, in real life, they are mounted up where the cylinder is, but we draw our circuit diagram to indicate the flow in an easier fashion. So we draw them down the bottom. But if you can just imagine them being mounted on the cylinder at the top. So as you can see now, the air supply can't go through the start push button because it's port 1 to 2 is closed, and it can't go through A1, but it can go through A0 from port 1 to port 2 because our cylinder is retracted and that valve is actually depressed. It's activated. A0 is activated because the cylinder, as we've drawn it in this diagram, is in the retracted position. So therefore it has to be activated. So as we did in our previous diagram, we need to have some automation of the cylinder. So therefore we need a 5 two-way valve that is going to control the position of the cylinder. So I've put the numbers of the 5 two-way valve for the pilot ports on either side on this diagram. So you can see on the left we've got port 14 controlled by A0, port 12 controlled by A1. So instead of having manual push buttons controlling our pilot ports to control the position of the cylinder, we're actually using our limit switches this time. So as it stands now, if we push our start button, the air supply will go through the start button, through A0, and it'll enter the 5 two-way valve, port 14, move it to the right, and send the air supply from port 1 out of port 4 and to the back of the cylinder, moving it outwards. When it gets to the extended position, A1 will be activated, A0 is now released, then the air supply will go through A1 and it will reset our 5 two-way valve at port 12, putting the air supply from port 1 to 2 and therefore retracting the cylinder. But we've been asked to do a few more things. We've been asked to send the cylinder out slowly and to retract it quickly. So when we want to send the cylinder out slowly, what we usually do is control the air supply that is going out of the cylinder, not the air supply going into the cylinder. This creates a buffer which makes the cylinder move much smoother. And we do this by means of a one-way flow control valve. So when this is mounted in the correct direction, the air supply moving down through the valve as the cylinder moves forwards has to go through the restrictor straight down, because that ball valve on the left is closing it off. But when your cylinder moves back again, the air supply moving upwards can flow past the restrictor through that one-way check valve and be able to help the cylinder get back quicker. In addition to this, we've mounted a quick exhaust on the left-hand side, or on the back of the cylinder, so that when the cylinder moves backwards, the air going out of the cylinder can exit directly at our quick exhaust, port 3, the exhaust port, without having to go all the way down the pipe and exiting our 5 two-way valve at port number 3 or port 5. Alright, so this allows us to have an automated circuit. We push the start button, the cylinder will move forwards to get to the end. A1 will reverse the direction of our 5 two-way valve and send the cylinder backwards. When it moves out, it's restricted in the speed, so it will move out slowly. When it moves back, it's unrestricted, and the exhaust gases can go directly out of the quick exhaust valve, allowing a quick return.